Today we're going to talk about section 2.5, which is scatterplots and correlation. So what is a scatterplot? Scatterplot is a graph used to determine whether there is a relationship between a paired set of data. We usually jot scatterplots from given real-life data that we have collected. And we set one value equal to x's and one value equals to y, and then we plot all those points on a graph. So all those points are scattered throughout, thus the name scatterplot. A scatterplot has certain correlation. We say that it has positive correlation when as the x's increase, so do the y's. So as you can see right here, I have a whole bunch of points in red scattered throughout. I have fit this blue line through them. That is called a best fit line. And since when all my points would fall right on that line, we would say our correlation coefficient or correlation factor, R, is equal to 1. 100% of the points fall on the line. But when they are close to the line, as these are, our R will be close to 1. I would say in this case, our R is about 0.9888. And we will always do correlation to 4 decimal places. If we have negative correlation, as my x's increase, my y's decrease. So you can see here all of these points scattered. If I try to fit a best fit line through there, pretty much looks like 100% of the points would fall on there. But notice my R is a negative 1 because it is a negative correlation, so it will be a negative 100% fit. This one up here we would call strong positive. This one, if it's exactly -1, we would call it exact negative. So we can have strong, weak, relatively strong, and it can be positive or negative. And our last situation would be relatively no correlation. That is when your R is really close to 0. There's actually no real pattern. Statistically, they say anything under 50%, 0.5, would be relatively no correlation. If we are 0.5 to 0.6, we would say we are moderately strong. If we are 0.7 and above, we would be very strong. So here is an example of all the different correlations. Notice on this one, there's relatively no correlation because it is very difficult just to draw one line through all those points. I'd say this correlation is something like 0.2105. This is a strong positive correlation because I can draw a line through these points. Relatively, all of them fall near that line. And this is a very strong negative correlation because more of the points fall towards that negative line. So my R will be close to a -1 here. All right, let's see how we put this in our calculator. So the first thing you're going to want on your calculator is, we don't know what this data stands for, which I don't like. It's just these are my x's and these are my y's. Where usually it's from real life, so it has a meaning to it. The number of days on my lemonade stand and the money I made. So let's just change this to days. And this is the money I made at my lemonade stand. So my X's are going to be my days, so I'm going to just jot that on my graph. My Y's are going to be the money, and this was a lemonade stand. All right, so to get this data in your calculator, you're first going to press your stat key. And then you're going to choose edit. Edit always allows us to put information into the calculator. So I'm going to hit enter. And I have data in mine. If you don't have data in yours, go ahead and put some numbers in. Because here's what I want you to get used to. Clearing out your data. To clear your data, you go up onto the list and hit clear, enter. I'm also going to clear my data out of list 1. Up onto the list, clear, enter. So in list 1, I'm going to put my X's. They are 1, 2, 3, 4, 5. So you press 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. And over here on list 2, you're going to press 10, 12, 15, 17, and 20. I still don't see a scatter plot of my data. So if I go above y equals, it says stat plot. Anything above a key is in blue. So you need your second key to do it. So second y equals. And I want to turn my first plot on. So hit enter. And then I should be blinking on the on. So I would hit enter to make sure I have it. This first type of graph is a scatter plot. This one is a line graph. This one is a bar graph. This is a box and whiskers with outliers, a box and whiskers, and this one is a logistics. It says my X's were in list 1, and I put my Y's in list 2. And these are the different markings, pixel markings that show up on your calculator. I like the big fat one so that we can see it. Then to actually see your data, once you turn this plot on, it will stay on until you turn it on. To actually see your data, press zoom 9. That is zoom stat, zoom 9. And we see this data. So I'm going to come over here and plot that data. To get my X increments and my Y increments, I'm going to press my window key. I see my X's go from 0.6 to 5.4. I see my first X is a 1, so 0.6 would be here. I see this X is a 5, so 5.4 would be here. Then I see my Y's go from 8.3 to 21.7. I see this first Y is 10, so this is going to have to be a little below it, 8.3. And this one is 20, so this would be 21.7. So $21.70, $8.30. All right, so there's my scatter plot. I have my X's and Y's labeled. I have my X's and Y's incremented. I have my scattering of points, and I have labeled what it is. All of those things are necessary for a true scatter plot. Now it says, write the equation of your line. So to get an equation, we use a mathematical process called regression. And ours is a line, so it will be linear regression. So to find that on your calculator, it is a statistical operation. So again, you will press stat. But this time, it is a calculation that we want. So we're going to go over and choose calculate. And you see number 4 here says linear regression, ax plus b, mx plus b. They just use the first letter in the alphabet, ax plus b. So I'm going to choose number 4. And our default lists are list 1 and list 2. So as long as you always put your information in list 1 and list 2, you can just press enter. And we see that I have y equals a 2.5x plus y-intercept 7.3. So I'm going to write that equation down. Y equals 2.5x plus 7.3. So there's the equation of my regression line. But I do not see my correlation. So to do that, you're going to press your mode key and go down until you get to diagnostics on. I don't have that feature on my calculator, so I have to go to catalog. And I want diagnostics on. And it says done. You would do mode and scroll down until you get to stat diagnostics. Highlight on and hit enter. And now I'm just going to do that regression again. Since I've turned on my diagnostics, it will stay on until I reset. So stat, calculate, for 4, enter. Now you see I have an R squared and an R. R squared is coefficient of determination and R is correlation. We are looking for correlation on linears. So my correlation is R equals 0.9976. And what can you tell me about that correlation? It is very strong, positive correlation. Because this is close to a positive 1. 99.76% of the points fall on the line. Then it says, enter the information into the calculator and compare and contrast. Well, what is the correlation factor? I already have that. Make a prediction for 10. So I am looking for f of 10. So I need to put this equation into the calculator. So I press my y equals. And I can just type that equation. 2.5x plus 7.5, enter. And I can go to my table. The table's in blue, so I'll go second table. And I'm looking for 10, so I'm going to scroll down to 10. And I see I get 32.5. So if I was to answer this question after 10 days, I made $32.50 at my lemonade stand. Now, if you don't like doing that, you could just, right on your calculator screen, type 2.5 times 10 plus 7.5. And I also get 32.5. Depending which way you like, you can do it either way. Okay. This is just about correlation. So it says, write an equation of a best fit line. We don't have these exact points, but we can see this is fairly strong. So I would say this is a strong, and it leads to the left, negative correlation. I can come up with an equation by picking any 2 points I want. So if I choose this point, it looks like exactly between 3 and 4, so that is 3.5, 0, 3.5, 0 on the x, 3.5 on the y. And this point is 2, 2. So I could calculate that equation. Y minus y sub 1, and use this point, which is 3.5, equals slope, which I haven't figured out, x minus x sub 1, which is 0. So to calculate my slope, change in y's, 3.5 minus 2 over 0 minus 2. That gives me 1.5 over negative 2, which gives me a negative 0.75. So negative 0.75x. Now I'm just going to complete my algebra. Y minus 3.5 equals negative 0.75x. Negative 0.75 times 0 is 0, so now I'm going to write it down. Add 3.5 to both sides. And I get y equals negative 2.75, excuse me, negative 0.75 x minus 3.5. And I have my equation from those 2 points on the actual line. Now, if ever our correlation was r equals 0.3467, and we got this equation to go with it, 1.5x plus 4 is y, and x stood for the number of hours spent sleeping, and y stood for the outlook on the day. It says make a prediction of hours spent positively on the outlook of the day. Make a prediction means find some x to put in there. I can still pick any x to put in here, but since my correlation is so weak, I would not trust this equation as a predictor. All right, one more problem to try to see what we remember on our calculator. The table shows that the number of U.S. births from 1990 to 1995 in thousands. Let x equal the year since 1990. We don't want to enter 1990, 1991, 1992 because the calculator looks at all numbers as numbers. So this would read it as 1,990 years. So if we say years since 1990, 1990 is 0 years since 1990. Change colors here. 91 is 1. 92 is 2 years. 3 years since 1990, 4, and 5. So for my years, for my x's, I'm going to enter 0, 1, 2, 3, 4, 5. And then for my y's, the number of births in thousands is 4,158,000. So 4,158,000 births in the United States. 4,111, 4,065, 4 million, 3,953,000, and 3,900,000. But again, we're entering it in simpler numbers. So our first step, our regression, stat, edit, I'm going to clear my list. My x's are 0, 1, 2, 3, 4, and 5. My y's are 4158, 4111. I always have to check because I get a little clicker happy. 4065, 4000, 3953, 3900. Then, since my stat plot is on, I can just go right to Zoom 9. So I need to sketch my own here. My x's are the years since 1990. My y's are the births in thousands. What is this of? U.S. births. Press my window. My x's go from negative 0.5 to 5.5. Over here would be negative 0.5. My y's, 3856.14. So if this one's 39, I'm going to go 3856.14 to 4201.86. So up here, 4201.86. And there's my scatter plot. Calculate the linear regression line for the data. So when it says to calculate the line, that's the equation. So y equals. So I'm going to go stat, calculate, for 4, enter. And we're always going to do 4 decimal places for the best exactness. So I get negative 52.2571 x plus 4161.8095. And my correlation R is negative because it is a negative correlation, 0.9989. So this would be strongly negative. Very strong negative. 99% of the points fall on the line. Very strong. And it says predict the number of births in the year 2000. So 2000 subtract 1990 is 10 years. So again, I'm looking for f of 10. So if I go to my y equals, and I type that equation in, negative. Make sure you use your negative key. 52.2571 x is right here, plus 4161.8095. Enter. And then I go to my table, so second graph. I see 10 is 3639.2. 3639.2. So to interpret that in thousands, it would be 3,639,200 births in the U.S. during 2000.